So this is the 2015 Junior Cert Higher Level Paper 2 and we're looking at question number 7. The diagram shows the triangle ABC. DE is parallel to BC. We can see there, they're indicated by the arrows. And the sizes of some of the angles are shown. Find the value of x. Okay, well, if you have parallel lines and a transversal, a line crossing them, you can find corresponding angles, alternate angles, or interior angles. So what I've spotted here is, if you look at this shape here, this kind of F shape, we know that under the branches of the F, that angle there will be equal to that one here because they're corresponding. So that means that this is 70 degrees because these are the two parallel lines and this is the transversal. So if this is 70, that must be 70 because they're corresponding. And then I now have values for the three angles in this small triangle. And I know the angles in a triangle add up to 180. So I can say that 2x plus 3x plus the 70 degree angle will add up to 180. So I've formed an equation and now I'm just going to solve this equation. 2x plus 3x is 5x plus 70 is equal to 180. I'm then going to take this plus 70, I'm going to bring it over here, make it negative. So that gives me 5x is equal to 180 minus 70, which is 110. And then I'm going to divide both sides by 5. 5's here cancel, leaving me with x is equal to 110 divided by 5, and that's 22. So the value of x is 22 degrees. That's my answer. Okay, part B, given that the size of the length of the side AE is 100, the length of AC is 130, and the length of DE is 74, find the value of BC. Okay, so AE is 100, AE is 100, AC is 130, so A down to C is 130, so that's the length of AC, this length, the whole thing. And DE is 74, find BC. So DE is 74, so 74 for this length, and we've to find BC. So I'm just going to call that Y, because X has already been used, so we want to find BC, which is Y. Okay, so, well, these triangles, there's two triangles here. There's the triangle AED, which is the small triangle, and the triangle ACB. And I'm going to draw the two of them separately. And because this angle here, 70, is equal to this one, and because the angle 2x is in both triangles, well, that means that this angle here is automatically equal to that. So when the three angles in a triangle are equal to the three angles in the other triangle, we have similar triangles. So I'm going to draw the two triangles out, AED and ACB. Draw a sketch. So there we go, we've got A, E, D, and then we've got A, C, B. So remember, AE is 100, AC is 130, DE is 74, and we're looking for CB or BC, which is Y. So if the triangles are similar, which they are because this angle is equal to that angle, this angle is that one, both 70, that means the third angle is automatically the same, so this angle is equal to this angle here. Well, I'm then allowed to say that there's a scale factor here. So what I'm allowed to say is that the big side here, the corresponding sides, if I divide 130 by its corresponding length on the other triangle, 100, that will be equal to this big side here, y, divided by its corresponding side, dE, which is 74. So the scale factor is the big divided by the small, the big side divided by the small side. So that's what I've done here in each case. So this creates an equation. So when I have a fraction equal to a fraction, I'm allowed to cross multiply. So that will give me 100 by y, and that's going to be equal to 130 by 74. So 130 times 74 is 9620. And then I'm going to divide both sides by 100, because these cancel here, leaving me with y equal to 96.2. And y was the side BC that we were looking for, so that's my answer. BC is 96.2, and that's the end of question 7.